Good afternoon, everybody, and a very warm and sunny, hopefully where you are. Welcome to this fourth episode of This is Simulation. So This is Simulation is a brand new web series brought to you by Sim & Skills. It champions the latest innovations in healthcare simulation. If you've missed any of our previous 3 episodes, please head to our website. There'll be a link going into the chat shortly where you can watch those episodes back at your leisure. I'm Nicola and I'm your host for this series, and I've got the great task of talking to some really fascinating guests. Each of our speakers works in a different area of healthcare simulation in different job roles, and they're going to share the work that they do, offering practical insights that hopefully you can take back to your own organisation. Just before we get underway with today's episode, just a few housekeeping things to make you aware of. Please use the chat box to say hi. If you're in the UK and you're experiencing an unusual heat wave, let us know how you're keeping cool. If you're international, let us know what the fuss is all about when it hits 27 degrees. We just can't cope in this country. So yeah, use the chat to say hi. Just make sure you've switched the little blue button at the bottom to everyone, not just hosts and panelists. Otherwise, it's just myself and Juliana who gets to see your lovely comment. I'm sure you'll have lots and lots of questions during today's session. Please put your questions into the Q&A section. So there's a separate Q&A section to the chat. That just means that we don't lose your question in amongst the chat. So you can pull both those up, say hi in the Q&A, and pop a question into the chat for us. Today's session is recorded, so if you need to jump off anywhere or you want to share this with your team, today's episode will be emailed to you tomorrow. Now on to today's episode and today's guest. So I'm really delighted to be joined today by Juliana Samson. She is a postgrad researcher and lecturer in virtual simulation at Coventry University, who specialises in the use of AI in healthcare simulation, pretty topic at the moment. And today she's going to be taking us under the hood of a virtual patient that's driven by generative AI. Welcome, Juliana.
Thank you. And as you can tell from my accent, I'm Australian, but I've been here for 20 years, so I'm acclimatised and I'm dying with the rest of you guys as well. So allow me to share my screen. And Nicola, can we see that? Fantastic. Okay, so as the promise lies, we are talking about conversational AI today, and specifically how that fits into a human-centered framework. Saying that, we will get a little bit technical just for those who want to know what's under the hood of a large language model as well. So this is the team. My background is in physiotherapy. Natasha is from paramedic science. Petros is from computer science, Nikki is from psychology, and Rosie is from nursing. And last but not least, pictured here is Sarah Potter. So she's our central character of this simulation story. Sarah is an 80-year-old woman with frailty syndrome, and she's a virtual patient that we've co-created with our industry partners, PCS Spark. So you can chat to Sarah via a screen device or a VR device, and she's driven by artificial intelligence. So let's look at the technical side first, and then we'll move into the all-important human side as well. So the broadest definition that fits this part of the artificial intelligence question is simulation of the intelligent behaviour by computers. And we know about algorithms, they're everywhere, but just to revise, they're a set of computer instructions. Now, what distinguishes machine learning from traditional computing is the situation whereby the programmer, or human, basically doesn't have to program at every step. Essentially, the machine learns from the training data. And it does this via a neural network. So this is loosely modelled on the human brain. And for those of you who might have a bit of a neuroscience background, you might find this helpful. The information in a human cell passes from the dendrite through the cell body, through the axon terminals, and across the synapse to a neighbouring neuron, or mini neurons, as we know in human brains. The equivalent of that is a node. So this is where the computer instructions are executed. You have the input, you have weights, which are essentially like coefficients that basically guide whether that function is activated or not, depending on the goal of the algorithm. And then what happens is you have an activation or a non-activation, as it might be. The output will then talk or not talk to other nodes in the network. So let's look at this network. We have an input layer, we have hidden layers, and we have an output layer. So this is capable of what we call deep learning. And in this situation, it's supervised learning because the data that's going into the system is labeled. You can see here pictures of cats and pictures of dogs and the labels associated with that. So what happens with an image recognition piece of network like this is that the information comes in part by part, maybe line by edge, and it all builds across this network. So when we get to the output layer, the job of this system is to classify whether we have a cat or a dog. Now, you'll remember I spoke about weights or coefficients. Initially, when these models are built, those weights are set at random. So it's not going to be great initially at picking out whether the image is a cat or a dog. But what happens with time is that it goes through a process of forward and backwards. Let me show you here. Propagation. So what happens is the system will work out the difference between what it predicted and what the training data is saying, and then it will go through this forwards and backwards to minimize that error. So after thousands, millions of passes, it gets better at learning and predicting. So in the situation where we have a language model that has a function rather for virtual patients instead of image recognition, what we would have is that the classification has questions and answers in the back end in relation to a conversational tree. Now, that's certainly how PCS Spark software worked previously before the advent of large language models. And we all know that the world's never been the same since, right? We have a huge volume of data going into a large language model. So this is where data is collected from the internet, books, blogs, social media, you name it, massive volumes of information. It has to go through a preparation stage. Tokenization is where you break it into the smallest parts, and also normalization where you format it so that the computer can read it. For example, getting rid of capital letters. Now, those of you who are of my age group might remember Transformers, that robot. So as it's capable of going from a robot to a car, so too are large language models able to translate the text information into numerical information. That's part of its processes. So it does this via what's called an attention mechanism. Before attention mechanisms, what happened is every word in a sentence would be analysed in sequence. Now it's all analysed at once, so you get a better context of what that word and its sort of sentiment within a sentence. And then you also have a situation that we have things working in parallel. So that basically means that you can chunk up to larger volumes of text and interpretation. So the architecture consists of an encoder and a decoder in a transformer. Now, the job of the encoder is to take, as I said, that text data, right, and turn it into numerical. So this basically represents what we call a vector. So it has a coordinate in an X, Y, and Z 3D space. And the premise is that anything that has similar meaning in terms of words will have similar places on this mathematical model. The information in the decoder is to take those vectors and make predictions. So it'll mask certain parts of that sentence. This is one technique, and make a prediction of what word comes next. And also it does it at a larger scale on next sentence prediction. So just like that other deep learning network that we showed you before, there's initially a difference between what the computer predicts and what the input data is actually depicting. So again, it goes through this forward and backwards propagation, and that will improve the prediction of the model. So let's revise where we are so far. A large language model will have a massive data set going into it. You'll have a process of deep learning via a neural network. It has transformer architecture. So that's basically your attention mechanisms, your encoder and your decoder, which allows for unsupervised or self-supervised learning. And then if you want to specialize a model, because at the moment it's general purpose, you do what's called fine tuning. So that actually goes back to putting labeled data sets in and specializing its function. And that's what PCS Spark did for their model, so that it could be a virtual patient rather than a virtual assistant. So they took, let's say, their 8 years of conversation data and fine-tuned the model. All large language models then go through an evaluation phase. So this is where you have metrics and you have human reinforcement training, and you provide the model with novel data. So for example, with a language translator, you would provide it with a text and ask it to translate it into another language, but this text would be novel. It wouldn't have been in the training data. And so similarly, when we're looking at a virtual patient, what you'd be doing is asking questions that you would be expecting students to commonly ask and refining that output. So what then happens is with all models is even after deployment, we have a situation where there's human reinforcement training, user feedback, and it continues to get better and better is the aim. So the thing to remember though is, and this illustrates it by PCS's diagram here, that AI with their programs are just the tip of the iceberg, because you can combine AI with your traditional programming and put it into a platform that's better fit for purpose for student education in this example. And you can see all the other things that have sort of been bolted and add on so that the AI becomes integrated into that system. Let's also consider AI more broadly. So Google talks about it being a field that encompasses more than computer science, data analytics, statistics, hardware and software engineering, and also extends to things such as linguistics, neuroscience, even philosophy and psychology. In fact, anything that considers human intelligence. Also, human-centered AI has become a larger concern since we've had the advent of large language models because of the issues of deepfakes, the issues of human rights, job security, and the environment, just to name a few. Now, there's also been a lot more attention on human-centered design, which is where our research comes in. We had 4 key stakeholder groups. We have students, educators, both in academia and in practice, and technologists. And together we co-created the prompts for this virtual patient, the story scenario, and the website that sits around. As we said, it's not just the AI. So in total, we had over 100 people involved across 20 organisations, and 59 were signed up for the research. And then we had that broader engagement as well. The aim was to provide a resource for occupational therapy and physiotherapy students to work together on a frailty case. So those who maybe aren't in the frailty space, or just to revise, this is a syndrome that's commonly associated with aging, and it is characterised by an increase in susceptibility to insults or minor injury because we've got a reduced energy, physical and mental reserve situation. So it can increase a person's risk of hospitalisation and nursing home admissions and mortality as well at the extreme. So we use design thinking as a concept to underpin our co-creation. And what this focuses on is the needs of the end users. So that's the students, first and foremost, who are using the technology, but also people with lived experience of frailty, which we're ultimately serving. And what was arrived at was a 3-part sort of simulation. Mission avoidance, as my participants rightly said, frailty doesn't start in the hospital, it starts in the community. So there's lots of moves towards that, and we need to simulate that in our scenario. Then an emergency scenario, and then the community scenario, which can also be expanded out to issues of end-of-life care or social health and well-being. So this is Sarah. Let's meet her.
Hello, my name is Sarah, and I'm a retired school teacher. I had a wonderful career teaching the children. I miss watching the students learn and grow, but I still get to read to my grandniece on occasion. Outside the classroom, my husband and I went on many, many adventures, and we enjoyed the company of many friends on our travels. Over the years, our adventures have somewhat slowed, but the company was always lively. Sadly, I lost my darling husband 6 months ago, and I still feel like part of me is missing. Walking out alone, just doesn't feel right. I felt like I was drowning those first few weeks after he died. But thankfully, my GP picked up on this, and the pills she gave me have really helped. My family have been so supportive, especially my sister who lives nearby. And although I don't get out to walk with her much these days, she visits me at home to keep me company. She also helps tidy the house and make me a meal when she can. My neighbour, she pops in to bring me shopping or just for a cup of tea and a chat. She's also there for me in case of emergencies, like yesterday when I slipped in the bathroom and I hurt my wrist. She took me straight to the GP to get it seen to.
So following on from that, we have resources where the student can follow her journey with her fractured wrist through the emergency department. 2 weeks later, she has another fall, and you can put a headset on and experience this from a point of view of Sarah. 6 months later, unfortunately, she fractures her hip and is admitted to hospital. So the students take the lead as clinicians and go through the clinical notes first. They look at investigations as well. And they can then speak with the avatar.
This is a virtual reality space, so you can watch it via a screen or you can chat to this virtual patient with a headset.
So today, let's jump into VR and have a chat. Hi there, Sarah. My name's Juliana. I'm a physiotherapist. How are you doing today?
I'm doing okay, thank you.
So tell me, how are you managing at home?
I struggle to get things done around the house. I just can't do it by myself anymore.
Would you consider getting help at home for this?
I don't want to be a burden on my sister and neighbor anymore. So maybe it's time to get help.
So then after the operation, we can look at the x-rays. This is an occupational therapy student who will be narrating what happens post-operatively in terms of her journey, as well as a physiotherapy student participating in the conversation. They also get the opportunity to look at the outcome measures and together plan her discharge into community. So that's phase 3. And again, another animation banner and a virtual home visit, so the students can work out where things need to be placed. And this is a microsim, which is another partner that we worked with to create essentially like a reflection on some of the earlier decisions that were made in Sarah's case. So where to from here? We could include other professions, obviously. This case scenario is being written up across 10 professions, and obviously the detail is in the occupational therapy and physiotherapy, but all the other details link up, and then that could be picked up by other teams. There could be additional cases. This is some examples of some of the avatars that are on the PCS suite. And from our student evaluations, we found the need. Of course, this would have been the case anyway because it was at prototype stage for instructional design, accessible design, some game mechanics in there, and most importantly, from the students' perspective, a community of practice so they don't feel isolated and in silos. So pleased to announce that this research has been accepted at a conference in Manchester, and I'll be presenting this in August. And look out for this title, but what I'll also do is I'll post that on LinkedIn, and there again is my QR code if anyone wants to stay in touch, and I'll open things up for questions.
Thank you so much, Juliana. AI is such a huge topic at the moment, and there's obviously a lot of different work going on. Looking specifically at your project there is 1 or 2 questions in the chat, so we'll come to those. So the project is at research phase at the moment, and you've mentioned that you're using PCS Spark, but it looks like there's some other tools that you're using to tell the patient story as well.
That's right. Yeah, so there's a whole range actually that I sort of had to reflect and gather up what we've used. things that we've had access to as a university, like the Adobe Suite, just for stock images, but also the Photoshop for like those watercolor animations. And there was an animation feature within Adobe for that. So really loving the Adobe Suite. That also has AI features within it. For the storytelling, we also used some large language models to sort of develop, maybe not that first one I showed you, but I think a couple of the other banners, we did that as well. So that was simply, you know, ChatGPT and Copilot that we used for those purposes. The 3D tours are cooler. So that's something we have a subscription to as a university. And so you can put assets within that, and then the students can click through that journey.
Just on that, sorry,
yeah.
Juliana, because Paul's asked in the chat about specifically about those videos. Is it
Yeah.
a 3D video or is it a 2D 360 video?
Okay, so yeah, it's 2D. So Cooler is 2D 360, whereas the next one that followed that, where Sarah was on the floor, is a 3D video. So we used the 3D camera to build that, and then edited that again using some Adobe stuff. We tidied things up and put that into the headset suite.
So one of the things, or one of the words that stood out to me when you were talking about AI, is that you were talking about co-creation. Because I think sometimes when you hear about AI, it feels like it almost can run itself. But actually, even looking at the, you're giving us a small insight into the project that you're working on, there's a lot of co-creating that needs to go on to create a really successful learning experience.
Absolutely. So like any simulation that you would have the input from all of the teams, including the end users, the perspective of what's happening with the educators. And AI in itself, I think, especially with this agentic AI that's coming out, everyone sort of, you get the impression that, you know, it's autonomous and it can do all these things without us. But actually, to this day at least, we're still very much needing to be in the loop. So it's from the design perspective, our philosophy is that we have all the range of stakeholders, but also in terms of evaluating the outputs, because like you've seen with that demo on large language models, it's a prediction. So it's never going to be 100% correct. And that's where the hallucinations come in, where it's at odds with, you know, the reality essentially. And so that's where, as humans, we need to be the judges of that output as well.
So Paul's, well, it's not so much, well, he's got two questions actually. Thank you so much, Paul, for putting those in. So he wanted to know how long it took to create those videos, and whether, I know you're working closely with PCS, who are the developer of the avatars that are using generative AI, whether they have a suite of tools where you can build the whole patient journey and scenario. He said he's experienced some of it, and it would make it quite hard to build a kind of narrative community in the way that you've used different tools to create that journey.
Yeah, so it is a challenge. And one of the advantages I've had, because I'm a full-time PhD, is this has been my job. And I appreciate that when people are, you know, having to put output and content, it's much harder from that perspective to be able to assemble everyone together, and you are using a lot of different tools. So what you've got within PCS Spark is the ability to prompt, so that you can get that avatar to talk within that particular story. But if you're putting, and also too, you can put notes within their system. We decided just to use the chat function just because of the way occupational therapy practice and everything's laid out. We did it all within like a WordPress website, and then we bolted on all the other pieces of software. But I can certainly dig up it was a YouTube video that taught me how to do those animations. So I spent a lot of time on YouTube over this PhD, just learning and upskilling, because my background is clinical. So yeah, I think you're quite right. The enemy is time, but I can shortcut stuff, and always happy to have chats with people if they, you know, say, well, how did you do that? And those sorts of things. So leave it with me and I'll get that link, and maybe later on, Nicola, you could email and circulate that out.
Yeah, sure. Yeah. So with the advent of large language models, so Beth asked the question about what is PCS. PCS is a virtual patient that's driven by AI, but Juliana's going to show us a demonstration of it in a minute, Beth, so you'll be able to see it in action. And you say, you know, AI is not perfect. It can hallucinate. I know in things I do with it, it hallucinates. So what would you sort of advise people to be cautious of if you are using AI as a communication tool?
So as a communication tool, what we found was this system is pretty accurate at sort of sticking to the scenario, but that didn't come for free, and it didn't come right away. So in our research, it was probably about, I think from memory, about 84% accurate, and we got it up to around 94, 96% accurate by improving the prompts. But also PCS Spark helped us out by putting training information back into the model as well. But that was sort of back-end work, because when we were researching this, large language literally landed. So they've got a lot more experience with that, and there's a lot more sort of accuracy in terms of that output. When you're using an off-the-shelf model, then you're going to have to work a lot harder, I think, around the prompts and steering, almost going through that process yourself in terms of picking out the output. But the way we did it was kind of fairly simple. Because I was working on the scenario, I had an understanding of what she should be answering, and then we just did loads of user testing. And that's certainly in a lot of the webinars I've been watching about AI in terms of the output. How do you put, how do you modify? The only way you can is to test it. So you've just got to test and then do loads and then feed it back in and change your prompts. You won't get it right on the first prompt. It took us 4, and we're getting to that level of accuracy. And that was with, all the team input that we had.
From my experience delving into AI, and it's not clinical, it's looking at marketing, but and I think probably is very relevant to using it in clinical as well, it seems to be that human involvement is the prompting, and actually learning how to prompt is a brand new skill. How you're actually going to work with this fantastic new tool to get the best out of it. Do you have any advice about how you can start learning how to prompt really effectively?
Yeah, I'm on that learning curve myself, because when we came out with this, and it was very much the focus was on how to build the scenario as a collaborative team, how to change the content to upgrade it. But lots more has come out since in terms of sort of like the science, I guess, of prompt engineering. And where I'm looking to go is there's a lot of sort of free tools. Google does some online where you can, and I think OpenAI have some really good guides. So they'll tell you how their machines best respond to certain prompts. And so it's that aspect. And I'm tempted to maybe do a little bit of Python. And it's not because programmers are still always going to be needed. And sure, you can automate a lot of that. And I don't want to be a programmer, but what it would teach is the logic of how computers think and how to then communicate with computers to get it to have a human output, if that makes sense.
Yeah, sure. Paul's made a really good point, which is probably something that a lot of people are thinking about. Large language models are still, I guess, in their infancy. They've sort of hit us with a bang in the last 12 months. But there are some things where perhaps it does put people off, and that Paul's mentioned some of them: the cost, the latency, and the robotic voices as well. Well, there's lots of different accents in this country, and also different accents around the world. How do you see these large language models or these AI-driven patient simulators progressing over the next 12 months based on what you are doing currently with your research?
So one thing we know is it's only going to improve. And one of the limitations, as you'll see when we do this demo, in terms of the graphics, is you can have better graphics. You could have, a metahuman. I could be an avatar, and that it's that good, some of the technology. But then you've got to balance it off against the size of the model. And can you use it on a device, or do you need like a whole CPU with, computer graphics sort of cards and all that sort of stuff too, who has that, right? So if you're going to scale it, then you have to trade off some of these things. So as models get lighter, sure, then you'll be able to improve the graphics and voices, and you'll have more natural sounding things, which you often see in, some of the stuff that's come out recently with sort of the cinematic stuff that's, that Google's been putting forward. But put that into a model where you have to interact backwards and forwards and scale it up and use it on devices, then you have to make those trade-offs at the moment. But it's going to improve. That we know, because that since 2022, look at what we've seen in terms of the sophistication of the models and how they're better integrating with other technologies. So I think watch this space largely.
Would you say, I guess, like any new technology, getting your team to adapt to it and be able to integrate it into what you're already doing? Like you said, it doesn't exist in isolation. It's not just, bam, we've got this new AI tool, run with it. Is there a certain learning curve that all faculty members need to undergo to get the best out of it?
Yeah, definitely. I mean, certainly with the example of PCS, that we've got the support of those. The other avenue, like I said, is maybe going through training to understand what, like, the types of prompts are appropriate, what the types of science. We're lucky enough to have educational technologists within the university who have a special interest as well. So they're the ones pointing me to those guides and saying, if you want to skill up in this area, so that you're able to be sort of literate in other types of models, by all means. Yeah, I think we would be used to that with any type of software. And that one software, as we showed with this, doesn't necessarily fit all the use cases, that you'll have to bring various things together. One of the things I tried to do in my project is showcase all the stuff that we had available to us at the time, and also made a point of doing some stuff that is free and open access, so that it's not that cost isn't always that barrier.
And Pramod asks, which models would you recommend? I'm just going to get him to just. Do you mean the large language models, the different types that are out there, or do you mean specifically about AI-driven patient simulator? I'll get him to put in the chat. Yes, LLMs. Which LLMs do you sort of recommend that you use?
For this purpose, so you're again, what you've got is almost your two ends of the spectrum as options. So with this, the PCS Spark have basically created like a smaller model, taken a smaller model and they fine-tuned it. With larger models, such as, I think from watching something recently, chat is at the top, but they kind of keep jostling for position as well. And it's going to depend on, like, for example, in Coventry, we've got license for Copilot. So we've got a corporate license with that. So then it comes down also to your institution. So what are they going to allow you to use from a security perspective? But yeah, a lot of those larger models are more general purpose. So they won't have the programming on top of it that makes it more seamless for the student experience, but they can still be used. It's just knowing that you're just going to have to do a little bit more work, I think, on the prompting and the front end of those. But yeah, the ones I've mostly had experience with, mainly because of the institution, is Copilot, and then everyone's used chat, but there's several others, Gemini and so forth.
So it's probably a good opportunity then for us to take a look at PCS Spark with you, because that's specifically looking at communicating with a patient avatar. And then I guess we could go into afterwards how that works as a large language model versus the bigger, more generic ones.
Yeah. I mean, one of the obvious things that is when you're using chat, it's a text interface, whereas this interface is quite different. So allow me to share my screen and let's have a play. Sounds on, and here is Sarah in hospital. Can we see that?
It's just starting. Yep, we can see her.
Okay, great. Hello there, my name's Juliana. I'm here from the physiotherapy team to see you.
Hello, Juliana.
Hello there. What would you prefer me to call you in terms of your preferred name?
You can call me Sarah.
And Sarah, how are you feeling today?
I'm feeling a bit anxious about my upcoming surgery, but I'm trying to stay positive.
What do you understand about the surgery that you're going to have?
I understand that the surgery is to replace the ball of my left hip joint.
That's right. And what specific concerns do you have? What specific concerns do you have about the surgery?
I'm concerned about the pain and how long it will take for me to recover.
Okay, so this is one of the things that physiotherapy can help you with. The hospital will be helping you with the pain relief, but we'll be helping you with the rehabilitation to speed up your recovery. How does that sound?
That sounds good. I appreciate your help.
No problem. What goals do you have for returning back home?
I would like to be able to walk around the house without assistance and get back to my normal routine.
And so how were you walking about before the surgery?
I was using my stick and leaning on furniture for support because I was unsteady on my feet.
And so after the hospital, you'll be discharged with a frame. But in time, we'll get you walking without the frame if you're managing that okay. How does that sound?
That sounds good. I appreciate your help.
And so are there any other things you'd like us to cover today?
No, I think that covers it for now.
Okay.
Thank you for your help.
Absolute pleasure. We'll see you after the operation. Are there any other questions that
Thank
you want
you,
to ask?
Juliana. I look forward to seeing you then.
Okay.
Does anybody have any questions to put to the avatar? There are some things that comments that people have put in the chat about how is there more physical movement? Obviously, she's in bed, but are there avatars that do move, or is it quite static?
No, so we're using this as a tool mainly for communication. What you can do though is, let me just click on the physical exam button to undress, and then you can take her vitals, those sorts of things. So it's mainly sort of like history taking, and then sort of largely this has been used for sort of medicine and nursing. You can use an otoscope. Let me see, you can. It'll give you lung sounds. Those sorts of things. But no, in terms of, that was one of the questions as a physiotherapist that I wondered, our assessments are largely based on sort of, the physical examination of getting them to move and do certain things. And this is where we used videos and sort of reporting on what had happened days 2 to 8, those sorts of things, and worked around that. So you played to the strengths of the tool, essentially.
On PCS, they have developed a speaker-only system, haven't they? Where it's not the animation; it's an ability to interact with, say, your patient simulator, your existing patient simulator that doesn't communicate, and you can have the speaker behind, and then you can respond in the same way as you do with this avatar. But it is, I guess, as you said earlier on, it's the size of the model that you're then limited with the graphics that you can access.
Yeah, it's the size of the AI alongside the graphics, but also the size of your device. So you can, they recommend that you use this on sort of PCs, but it can be used on tablets and phones as well when I've tried it, and it works fairly well. But yeah, that certainly would slow down if you amped up sort of some of the other features. But yeah, again, watch this space.
And Michelle from PCS is on the call, and she said that there are different avatars with different animations and appearances. So there's avatars with animations that have an agitated state and simulate withdrawal symptoms. But this is the patient that you've been using for your research project.
That's right. Hey, Michelle. So Michelle's helped us out with the research as well.
So with your project in mind, and with large language models that we might be used to using, things like ChatGPT, as you said, they're kind of pulling from a huge source of information. What's different with language models in terms of something like what PCS has developed so that it can be more aligned to medical?
So one of the things is all the programming on top of that. So you can see there's the suite and you can go through the different sort of modes of, assessment. It has evaluation features in it as well. And obviously it's not a text output. So you've got sort of that interaction happening within the model and within the space. So they're some of the things that differentiate. One of the other things is that fine tuning. So everyone knows when you're working with something like chat, it's trained to be a personal assistant. So it's always trying to help you out. And one of the things that they had to almost like train out of the model by putting this fine tuning process in is that ability of the AI to keep trying to help you. So you would ask her, what she eat, and then I've seen this with some of the off-the-shelf models that have just been that they've tried to just plug it into models. It'll start giving you dietary advice. And you're like, no, you're the patient. So it's the role aspect of it as well that differentiates. And also too, it's the scalability. So if you have a larger model like chat, then to be able to run that simultaneously and on a platform that you can track all your learners becomes a massive task, because if you have a smaller model that's more bespoke trained as a proprietary model as this is, then that differentiates. So that it's, it's not right or wrong. There's just different options, and knowing where the strengths of each type of option. Obviously, the strength of off the shelf is the cost issue, but then it's always considering the security issues of your institution, all those aspects as well in terms of the compliance.
So you found that the more that you use a model like this to create a virtual patient, the more that it is learning, so the responses that you're getting are more authentic to what you would receive from an actual patient?
With a large language model, it doesn't work the same way as machine learning used to. So a classification model, yes, it did. So it would take your responses, and then you could, but what you can do with this is you can train up the data. So with a large language model, every time you ask the question, it'll come out with a probabilistic response. So it'll be different every time, because it depends on the previous questions that you've asked as well. So the whole prompt that we put in goes in, but each question that the student asks also goes in. So there's that aspect of it. But then when you close the session, then come back into another session, it's going to be different again. So it's a different type. The type of learning that occurs isn't so much a learning from ongoing data that's put in from the user, but the evaluation that the team will do, and then they can put in what's called training samples. So essentially, you're like, okay, I've changed the prompts as much as I could to try and get it to answer this way, and it's still answering off in this way some of the time, say. Then what the team can do is they can put training samples in, say, when this question's asked, answer this way. So it's a different type of training, and in that way it learns.
If you've got any questions for Juliana, please put them in the chat or the Q&A. We've got a few more minutes left where she can take your questions. Juliana, would you say that practicing those prompts and being very, very specific about what you include in the prompts is a really key way to getting the right kind of interaction with the patient that you're creating?
Yeah, absolutely. One thing that we learned through the research, and because again, it was everyone exploring the world, physios, us not knowing what this new world was going to look like. The initial idea was to keep the prompts short and get the sort of model to sort of confabulate and tell the story around it. The issue with that is it wasn't sticking to the story and the clinical facts of the story as we needed to. So we almost flipped that idea and put the idea now is to put as much as you can. So the context window will allow up to about 2,000 words, if I'm not mistaken, certainly 12 to 1,500. And you basically putting as much information, not just clinically, and this is one of the outputs of our paper, spoiler alert, you want to be putting sort of information about that person's story and who they are. So it's almost in the way that you would brief a simulated patient, an actor. You would give them those sort of aspects of character, and they seem to lift that level of conversation and have that human-centered focus in theme again. So yeah, it really does, I think. And again, I think the best place for people is to not worry, just start, just play, and you'll get better at it by interacting. Even with the large language models, even if you're not an expert in that, you give a context, give a story, and then if it doesn't give you what you want, you're going to go back and do it again. You'll get better just by doing that as well.
Sure.
And just iterate, definitely.
And so that's almost like a pre-brief, I suppose, in the same way that you might give a simulated patient. Your prompting is your pre-brief. So within your team and your research, have you looked at debriefing in terms of, it's your research, so you probably are, but in terms of people using AI, is really important to think about how it has worked and go back and reevaluate those prompts and go back in and change?
So with our research, it was very, very much proof of concept because there was so much shifting and changing at the time. So what we did do is we went through sort of that consultation with PCS Spark on one end, our participants on another end, experts on the another part, changing the scenario as we went, which isn't ideally how you would do it if you wanted to do scientific research as to what worked, what didn't work. It's sort of essentially a start point. So it was very sort of messy, iterative, agile, and that's fine. Because one thing we did for that, and you'll have noticed in the title, is we called it a pilot, because in all good consciousness we couldn't call it anything else. But it did bring up some features about sort of you know, what the ideal is in terms of how to prompt, like we said, the story, those aspects. We took it to students and we basically went along the lines of feasibility, usability. Does this like whole suite of activities that we've created, do you come out with the right assessment, right response? And we know that worked. And then we took them together and had a very sort of, because it was co-creative, sort of very open, qualitative discussion about it. And they pointed us towards some of those future directions, which I listed on the slides. I would absolutely love to get into the metrics in future and say, okay, we standardize this, we do this one thing at a time, we get linguists involved and computer scientists involved, and we do this moving forward. But that, I guess this was the preliminary work to setting that stage, and then we'll be able to get more quantifiable statistics and evaluation moving on from that.
So in one of the videos that you had a headset on interacting with PCS.
Yeah.
Paul would like to know whether you can use it in an immersive room such as an igloo to be able to have small teaching groups with it around you.
Yeah, 100%. We did that within our evaluation because they'd literally opened this VR suite within the university, and we thought, well, we might as well use it. So yeah, we essentially delivered it on screen, students individually chatting with, you know, sort of to reduce the crosstalk, sort of just your traditional sort of headset earphone mics, and spaced out in a computer lab. We had them with headsets, and then we had them all in a room interacting as well. So yeah, you could absolutely throw other features in, because you can project up into that space.
One of those three modalities that you just talked about there, did you see any effect on the learning, or whether there was a preference from the students?
We hadn't asked those questions, so it was literally it was a mashup. No, so again, I mean, it's funny because you go through this sort of like initial process of sort of creating this and taking on this evaluation, and then you come out with a million questions afterwards. I guess that's, you know, that horrible line, isn't it? Oh, more research is needed. But I guess in this case, it's very much a starting point.
I think you mentioned earlier on about the limitations or the demands that AI can put on hardware. Pramod would like to know what sort of PC recommendations for like what specs you need to be able to run something like PCS? What does it run best on?
That would be a question for their technical team, absolutely. So it may be that we follow that one up. I don't know if Michelle can drop it in the chat, or I said I wouldn't put her on the spot, or we can come back afterwards regards that, because I definitely owe, was it Paul, like a link to the how to do the watercolors as well.
Yeah.
What I can say is from my own use, it doesn't seem to be anything special. I think that the whole idea is to try and keep the spec fairly low so that it is accessible across the learners, which is why as I say, that all those compromises have been made to keep the software light. I mean, I'm using just a standard laptop that's been issued by the university. It was issued 3 years ago, works fine. I just saw that. It works from a cloud. Yes. So essentially, as long as you can hold that signal in a cloud-based software, you're not tethering to hardware.
Just a good broadband system.
Yeah.
Which of course everybody's got.
Yeah, exactly. And I think some of the delays are a little unfair with the software sometimes when I'm demoing this. I took care to not have a million tabs open, and then I'm in North Yorkshire, for as lovely as it is, it can be a bit patchy sometimes.
Michelle, you might be able to see in the chat, Michelle from PCS has just put as like a page test to ensure that you can have a smooth experience. But I guess with any technology, it's getting that buy-in, isn't it, from everybody and like some of the attendees have put some really useful comments in about, it's some things do put you off looking into AI. It's the graphics limitations, the limitations of what the software can do. But as you've alluded to before, it's a technology that's still quite in its infancy, and it's still developing constantly and really rapidly.
Freakishly rapidly paced. I mean, I was talking with one of my colleagues who uses this over at Liverpool University, and something that he said really resonated as well. And it's for simulation in general. It's all in the pre-brief. So we sort of almost get those objections out of the way first. It's not real human. It's like, obviously, but it's a tool which you can use to practice your skills. You can pause and replay, and all those sorts of strengths really sort of like hit that up at the start and get that pre-brief so that you can sort of almost suspend that disbelief and get into the lesson.
And I think what struck me most is there's often a constant fear of AI is taking your job and AI is going to do this and this, take that away from you. But actually what you've shown is that the human involvement in AI, from the prompting and the evaluating, is crucial. It's not going to work without you.
Yeah, and hopefully giving you that look under the hood about how it works reassures people as well. You know, that because it has a word output, it's really sort of like seductive to think, oh yeah, it's like thinking things and it's reasoning things. It's really just converting them to ones and zeros, putting them through a computer and then spitting out a probabilistic answer. So yeah, hopefully that's reassuring.
Craig's put, AI won't take your job, but a person using AI will, which is very, very true, Craig.
I've seen that one about, and I think that's very true. There's another way of thinking about it, right, though, is if AI has come about and now all of a sudden the bar's been lifted, everyone can write to a certain standard, you know, we've got this, everyone can do stuff a bit faster, assuming that you are embracing it, then what's left? It's actually the 21st century skills. It's the ability to be with people face to face. It's the ability to have those conversations, to have the humor, to have the empathy, all those aspects that, you know, won't be replaced. Maybe they're going to be in more demand because that will stand us out above, hopefully.
People said AI might make your job more fun. And if you've got a spot,
it certainly made my job more fun.
Yeah. If you've got to spot an image where somebody's got a foot for a hand and a hand for a foot, and you're going to get a giggle off it, that's, you know, that's all good.
100%, yeah. So yeah, definitely. I think there's no doubt we're going through a crazy, like, just on the edge of a societal change that there'll be jobs we don't necessarily even recognize. You know, it's where do I go with this? I know where I'd like to from a research perspective, but things move so fast that the job I may land might not even exist yet. You know, it's just embracing that, I suppose.
Well, thank you so much for joining us today, Juliana, to talk through your research and your insights into AI. And yeah, as we can see, it's just at its infancy, and we look forward to seeing your research when it's been fully published, so we can see and take some of those insights from your research. But it's been incredibly useful. If you want to connect with Juliana, she's on LinkedIn. My colleague Ellie might be able to Dr. in it. She might be able to find the slide again to get your details back up if anybody wants to find you on LinkedIn and find out more about it. If you want to find out more about PCS, other large language models are available, but from us specifically at Swimming Skills, we work with PCS, with both the PCS that you saw on screen, but also SimVox, which is a version of PCS where you don't have the animations. It's a way to interact with your existing mannequin. So yeah, there we go on screen now. If you'd like to get in contact with Juliana on LinkedIn, she'd be more than happy to chat with you further.
Absolutely, yeah.
Sorry, you get bombarded now, Juliana, sorry. To the AI expert for us. So we've got 2 more episodes in this current run of This Is Simulation. In 2 weeks' time, we're chatting to Professor Jo Davis from Swansea University. She's going to be discussing how to grow your sim centre sustainably. And then 2 weeks after that, we've got another episode where we have Lindsay McLeish from Oxford University talking about simulated practice learning, particularly for nursing undergraduate programmes. So if you would like to sign up for those episodes, you can scan the code on screen now. There'll be a link going into the chat in a second. And like I said, if you've missed any of the episodes in the series so far, you can go back and watch those. Today's episode will be emailed to you tomorrow, so you can have a look back if you've missed anything. There was a lot to take on board with it being AI. But thank you so much, everybody, for joining us today. We really appreciate you joining us, and we'll see you on the next episode.